all stars start off as a nebula. It is a cloud of dust and gas. The gas is mainly hydrogen. Now, over time, gravity pulls that cloud of gas together, which causes temperature to increase. A lot of the gravitational potential energy that was stored in all of those particles in the cloud of gas, when they get pulled together by their own gravity, turns into kinetic energy, which causes the temperature to increase. And eventually that temperature gets high enough through the protostar stage for fusion of hydrogen to helium to occur. And this is what defines the main sequence of the star. Like our own sun, stars shine because fusion of hydrogen to helium releases a huge amount of energy in the form of electromagnetic radiation. And when this is happening on the main sequence, the stars are very stable. The outwards pressure caused by the nuclear fusion reactions and the gas pressure is balanced by gravity trying to pull humans on the star. And eventually, one day when the hydrogen in the core of the sun runs out, the star will become unstable and start to expand. So for stars like our sun, of similar mass, they turn into something called a red giant. So the hydrogen in the core has run out. There can be some fusion of helium to some heavy elements, but the key thing is the star expands greatly, it cools, and eventually, when all the fusion stops, all of the outer layers of the star drift off into space, and all that's left behind is a white dwarf. It's the remnants of the core of the star. It's incredibly dense, there's no more fusion, it's like the dead remains at the center of the star. And we think that over trillions of years, they eventually cool to become black dwarfs. For stars much larger than the sun, rather than the red giant, we have the red supergiant phase. So when the hydrogen in the core runs out, we have fusion of various elements all the way up to iron. Now, when this happens, when we get to iron in the center of the core, iron doesn't fuse anymore, and the fusion reactions suddenly stop. So there's now no more outward pressure, and the whole star collapses in a catastrophic implosion, which actually causes then a rebound explosion called a supernova. It's an incredibly violent event, which then leaves behind one of two things: a neutron star or a black hole. A neutron star is so dense, it's got about the same density as an atomic nucleus. We're talking about something trillions of times more dense than anything on Earth. A black hole is so dense that not even light can escape. The last key difference we should be aware of between stars of similar mass to the sun compared to the much larger stars is actually the main sequence. The smaller stars stay on the main sequence for much longer because the temperatures aren't as big, the pressures aren't as extreme, they fuse hydrogen to helium much more slowly, they can stay on the main sequence for a lot longer. The stars that are much larger, because they've got such extreme conditions, it's so much hotter in the core, the pressure is so much higher, they fuse the hydrogen much faster, they actually spend much less time on the main sequence, the whole life cycle happens much faster.